would like to ask my next speakers here. Tim Dirks from the company sewts is going to talk about sewts pushing the boundaries of industrial automation technology. So Tim, the next 8 minutes, you have the floor.
Awesome. Thank you very much for the introduction. Before I actually start with the pitch, I have a question for the audience. Who of you in the last 2 months actually took a flight? Okay, I see quite some hands. So you all know that's bad for the environment, right? We have a very high CO2 footprint in that. But I'm not here to shame you. I'm here to talk about an industry that's even worse than what we have with commercial flying. And that's the fashion industry. It's actually the second most polluting industry we have in the world right now. And as global warming is a huge problem, this is something we should definitely take a look at. It is actually 80 times more polluting than all flights and cruises combined. So how is it that this problem is such a big problem? Well, first of all, you have the logistics of this industry. So you have cotton, mostly coming from the US and China, going somewhere into Southeast Asia, where it is then processed into garments, shipped over to Europe or the US, the biggest consumer markets. And when a t-shirt or any other clothing arrives here, it already has traveled 40,000 kilometers. And that is not all. Actually, half of all fashion is thrown away without being ever worn because labels overproduce, because the logistics chain is so large. If they sell well, they have to add up for the margin. So why have we not solved or tackled this problem yet? Why are we able to almost send a human to Mars, but we cannot make local production of clothing a reality? Well, I think it is not a technical problem. We're on a tech fair here, right? But if you took 100 engineers and put them in a room for 5 years with the proper motivation and funding, they'd solve you any problem we have here. But the problem is an economic one. So if you add up the salaries and the costs that those 100 engineers would take to come up with a t-shirt sewing robot, for example, you could make 100 million t-shirts somewhere in Southeast Asia. So I would certainly not invest in such a venture. I'm sure you wouldn't either. And we think we have still found a solution for that. We have to bring down the engineering costs when it comes to the textile markets. We're developing an engineering platform for easily deformable materials where we want to enable engineers to make these processes a reality. We want to be sure that you can take any kind of input into a process of any textile, a random shape, whatever it is, let the engineer work with our software, and then help them come to a solution and bring it into a defined state where classic automation can take over. We think that with this technology, we can reduce the cost of engineering by tenfold. Our solution for that is called Sewts Jupiter. So what have we done so far to prove our worth? This is just an idea, right? So based on Sewts Jupiter, we have developed a first use case right here in Germany in industrial laundries, where the problem I just showcased, picking a towel from a bin, random position, placing it into a defined state and placing it on a folding machine is an actual problem our industry has here. We have solved this problem. We'll bring our first series product, a machine that can handle this, to market within the next month. We have already sold 3 more units of that, and we're going to spend 2023 to scale up this idea. So where does this all lead us? How do we come from this one use case to a final engineering platform, Sewts Jupiter? We plan to tackle 2 more scalable industries to further develop features within the pipeline of this tool. We want to tackle e-commerce return handling for clothing. All of you are now ordering your clothing online, and I am not going to ask who's sending back a lot of it. This is all going to Eastern Europe to be hand processed and then comes back to fulfillment centers. This is our next use case. The one after we want to tackle is clothes sewing. And when we have all the features for this engineering platform together, we want to go and make it available to engineers around the globe to make Sewts Jupiter what CAD was to the drawing board. My name is Tim Dirks. I'm one of the co-founders and CTO of Sewts. And if you're looking for a partnership or for a nice investment, please come talk to me at the booth later on.
Thank you. Thank you, Tim, for introducing Sewts. Questions? There's one.
Sorry. Great presentation. I wasn't aware. By the way, I have two questions. Who's the #1 in polluting industry, just for my reference?
Oil and gas.
Oil and gas, yeah. All right. So one thing I don't understand, so you have a 3 steps approach, first laundry, then e-commerce, and then clothing. Are you planning on selling in these 3 different categories?
Yes. So we have figured over developing our first product that it takes quite a long time in classical engineering, and you build a lot of skills that you think you cannot reuse somewhere else. So we see ourselves as our first customers for Sewts Jupiter eventually, and by that being, let's say, like Amazon was for AWS, where they built a pipeline internally to handle all their data structures and so on, and then make it available as a public product. That's the road we want to go.
I'm not sure about the role of machine vision in your technology. Could you elaborate on that a little bit?
Sure. I don't
You
have
need your presentation?
If I can,
Yeah.
I can also elaborate like that. So what we built into this engineering tool is the ability to virtually handle limp materials like textiles. So there's a simulation aspect for the material handling. Then there's a vision aspect, because for any kind of grasping step we need 2D and 3D vision. We're already working on simulating images to take synthetic data to train our vision, because in the future we do not want to label all the data anymore. And a third part of that solution will be in the realm of dexterity and sensor technology. So with these 3 together, we believe we can make the platform happen, and vision plays a big part as one of the 3 pillars there.
So you give a lot of dexterity to robots that robots today don't have.
We give dexterity and the ability to understand certain materials also through vision, because you as a human, if you pick a t-shirt at a collar, you know how it will behave, and this is something that is, let's say, a crossover between vision and material handling.
So if I as a human see a blouse made of silk and a heavy woolen sweater, my brain knows how to handle it.
Yes, or it thinks it knows. You could also make